Unit 12 practice test part 5, our last video. This is a little bit longer than I thought it would take, but we're on to question 23. And 23 says a sweater costs $159 now. So that's A sub 1. Okay. Assuming an annual 9% price increase, find the general rule. Using the general rule, find the price 5 years from now. So here's where people get themselves in trouble. They recognize that the increase is a percentage, 9%. So this is a geo. We haven't done a lot of these in the practice, but it's a geo one. 9% is not the R. It's only, remember, whenever you're doing these geo-type problems, these geometric ones, you have to find A sub 1 and A sub 2. So basically, if I do 159 times 0.09, that's going to give me the increase from 1 year to the next. That's 14.13. So if A sub, so let me just kind of create my little series. So my next one is not 14. It's going to be that plus the original amount, and that is 17331. So that's A sub 2. Okay. Here's A sub 1. Here's A sub 2. Now I can do right over left and figure out what the actual R is. So many people are trying to figure this out by using the wrong R. Okay. And then divide this by 159, and R comes out to be 1.09. If you haven't seen that relationship happen where it's 1 and then plus the percent. Okay. So that's R. Alright? We want to know basically what it's going to cost 5 years from now. So you need the rule. So we're going to use A sub n equals A sub 1 R to the n minus 1. Okay, so let's create the general rule first. We need A sub 1 and we need R to do that, and that's R right there. So we're basically going to say A sub n equals 159 times 1.09 to the n minus 1. So there's our general rule. So let's see, 5 years from now. So that means, kind of coming down here, we got right now, then we got 1, 2, 3, 4, 5 years later. So this is A sub 1, 2, 3, 4, 5, 6. Be careful there, not A sub 5, A sub 6. So we're basically going to do A sub 6, that's what we want to know. 5 years from now, 159 is going to be 109 to the 6 minus 1. And then we're basically looking at 1.09 to the 5th. Alright, we're going to figure that out. Let me grab a quick calculator here. So 1.09 all raised to the 5th is 1.53 times 159 equals A sub 6 equals 244.64. Okay, and that would be actually a dollar amount, right? All right, question number 24. Number 24 is our bouncing ball question, or rubber ball here. And remember what I told you here, these rubber balls always use infinite sums. The relationship acts like a infinite sum. So a rubber ball is dropped from a height of 400 centimeters. So here we are, and we drop the ball, and it goes down, and then it bounces back up, and it goes down again, and then it bounces back up, and it goes down again. Here's the key. You need to remember that we need to treat these as complete cycles. Okay? A sub 1 is from here all the way to here. A sub 2 is from here all the way to here. So this traveled 400, so I also added 400. So A sub 1 is 800. Alright? This formula requires us to do this. Alright? That's the infinite sum formula. So it's minus A sub 1 over 1 minus R. So I have A sub 1, so I'm already doing pretty good here. Alright? Got one of the unknowns. And I don't need to worry about finding A sub 2, but what I know is that it recoils 3/4 of the next one, or is this one. So that's going to be 1 minus 3/4, and that's our R. Okay. So now work this out. We're basically looking at S equals 800 all over, you can convert that to 4 over 4, and that is 1/4, and that means 800 times 4, and S equals 3200. And a lot of people feel really good about themselves and they're ready to move on, but the reality is we added this 400, and for the rest of it, it worked out just fine. So I need to subtract the original 400, and then I'm looking at 2800 as my actual amount. Okay. Last question. Sorry, that was 24, not 23. All right, 25 says write the decimal 0.424242 as a fraction of the lowest term. So that means you have to reduce. Remember, we can, if we treat this, if I treat it like this, can you see what I'm doing here? I'm simply, if I add all these up, you can see how it turns into the same thing as I have written over there, right? So I'm basically turning this repeating decimal into an infinite sum. Okay? And you see basically from each one, this is a sub 1 right here basically, a sub 2 and a sub 3, and we can keep on going. You can see how it keeps moving the decimal point over two spaces. So this is geometric, right? And these also act like an infinite sum because this goes on technically forever. So we're using our infinite sum. So we're going to use this again. Okay, we're going to do it to find a formula though, so or a decimal fraction. So let's see if we can figure this out. A sub 1 is 0.42. We just need to find R. Well, this is a sub 2. This is a sub 1. So this is really right over left. I know it's underneath, but this is right over left. So R is equal to 0.0042 all over 0.42, and then R equals 0.0042 divided by 0.42. You can see it's really a question of just moving decimal places, and R equals 0.1. Okay, so we're going to do minus 0.1, and then this equals 0.42 all over 0.99. Right? 0.99. Now, don't put that in your calculator. You're just going to get the 0.42424242. We want a simplified fraction. So, first thing I'm going to do is I'm going to multiply by 100 to move the decimal place two places, and that gives me 42 all over 99. Okay. Now that's the fraction that creates this, but I need to reduce it if it can be reduced. And both of these can be divided by 3. So we're basically looking at 14 all over 33. Okay, and that, if you put that into your calculator, let's see if I can put that up here on the dot camera, and say, let's give it a little bit of light here. 14 divided by 33 does equal 0.424242 forever. All right. So good luck.